Hello and welcome to this video. Today I'm going to share with you my antenna design. Over here I tried to replicate the real-world environment of an earbud. So I created a rectangle to represent the human head, a small gap between the head and the actual earbud structure. This is my antenna, a single wire path that folds back and forth like a maze. This graph shows the S11, which tells us how the antenna traps the signal. Anything below minus 10 dB is passing grade, meaning our antenna is catching the signal beautifully. Our directivity is at 4.56 dBi. The bright red colors shows that the signal spreads out in a wide round shape, and this is exactly what we want from an earbud. So the music doesn't cut out when you turn your head away from your phone. This isn't a perfect smooth circle. The internal parts of the earbud block the signal a little bit, creating a few smaller dents in the shape. The gain, minus 3.09 dBi. Negative numbers might sound bad, but for tiny gadgets like earbuds, it's completely normal because the plastic case and internal battery absorb a lot of energy and turn it into tiny amounts of heat. But the coolest part, when we change to the realized gain, the number only drops a tiny bit to minus 3.403 dBi. The difference is almost nothing, and this tells us that our design is highly efficient at feeding power into the antenna without wasting any of it at the starting plug. Okay, so lately I've been working on this earbud, and I want to share with you the things that I've learned. So first I will go to new template, select microwaves and RF/optical, and then antennas. Next, wire. Next, and I will choose this solver. I'll keep the default settings and select the minimum and maximum frequency. So 2.4, 2.48. And I want to monitor the E field, the H and the far field. Then next, give it a name. And finish. This is the space. I'm going to start with creating the box that represents the human head. So I'll go to modeling, and in shapes I will select brick, and instead of drawing it manually, I'll just click escape and create it in a more precise way and using parameters. So after I hit escape, I will just name it to head. X mean will be head width over 2, and it is in the minus. So this is the plus x and the minus x. So this is the plus x-axis and this is the minus. And over here is the same but in the positive. And for the height, I will name it. So by parameters, I'm just creating names and then I will give them the value minus head height over 2. And here is the head height over 2. Same goes with the Z mean and Z max. So here is a head depth. And here the head depth over 2. If I want to preview, we need to set the value. So I'll choose 25 or 50. This is the width, the height also 50, and the depth I'll make it 150. So this is the preview, and I will hit OK. Next I will change the material. I could have changed it from there, but I forgot. So I'll go to components, then the head. I'll right click and assign material and color. And this, from here, I'll go to load from material library. I'll choose this one and load. Okay. Next, I will create a small square to act as a gap. So the same thing, I will go to modeling, shapes, then brick, hit escape, change the name to gap. I'll choose x mean to be 25 and x max to be 25 plus the gap width. Y mean will be gap height over 2 and the minus and the max and the positive. And for the Z as well, gap depth over 2 So when I hit preview, I need to set the parameter. The width is 5, so 5 millimeters, as well as the gap height, 5 millimeters, and the depth. So here it is, exactly where I want it to be. I'll click OK. Again, I forgot to set the material over there. So I'll go back here, right click and assign material. And I want it to be vacuum. Perfect. All right. Now I created an earbud step file in CAD software, and I will have just to import it into CST Studio. So I'll go to import 3D files and step. So I'll click here to upload it, to upload them over here, and then open. And we need to make sure to click to check the scale to current units. Otherwise, you might find the parts very small. Okay, so right now I need to change the material of these parts and the location. First of all, I'm going to select all of the parts and then right click and transform. I will translate that. Or first I want to twist or rotate it over the x-axis. of 270 degrees. Can preview and hit apply. This will pops up, and we don't need to add or subtract or do any Boolean combination to the parts with the head component that we created. So I'll just keep it to none and hit OK. For all of the parts, so one, this is the second, the third, and the fourth. So the four parts. And now I have to drag it over here, and that distance is the head width over 2 plus 5 millimeters, which is 30. And translate. Yep. Preview, apply, and OK. All right, now to the interesting part, creating the antenna inside the earbud. What I'm gonna do is hide the components, some components, so it can be easy for me to design my antenna. In this area, I will start off by designing a sheet which represents the flexible board or the flex PCB. So I'll go to pick point and double click on this point over here, and then click on the local WCS, and then align WCS. And now we have a plane over here, but I want the U axis to be in the place of the W. I'll show you the reason why. Right now I will create my flex sheet, so I'll go to Curves, Polygon, and always I will not create the shape manually. I'll just escape and set parameters, so later I can adjust them easily in the parameter list. And the point is, over here I have the U and the V axis, so I need to draw my flex sheet in this face, not this face. So I'll just rotate this local WCS, and to do that I'll go to transform the working coordinate system, and from here I want to rotate. Can hit preview. So I'll rotate over the V. Counterclockwise, this is correct. Perfect. Next I'll go again to Curves, Polygon, hit Escape, name the flex board. In the U point, I will start from 0. The V point is 0 as well. Now we are in this point to go over here. Yeah, I know this shape, so it's like 5 millimeters by 22 millimeters. So to go from here to here, the U will have 5 millimeters. I'll just name this FB width, and the V still 0. So yeah, I'll give it 5, and the V will have a 0. So you can see that we went from here until here. Now we need to go up until here. the U point will still the same, and the V will be the height. So FB, right, and it's 22 millimeters. To go back, this will stay the same. I mean, to go back here to this point, this will be the same, and the U is 0. And to come back to the 0 point, 0 over here, and 0 over here. Then, okay. Now we created a curve, so we'll go to curves over here, select it, and then go to shapes, and from here extrude curve. So double click so it's selected. I'll just press enter and name that again flex board, flex PCB, printed circuit board. And the thickness, I'll set it to 0.15, or I can just give it a name, and I can change it later in the parameter list if I need it to. So FB, thickness, hit preview, and I will set it to 0.15 millimeters. Okay, and I need to make sure that it goes outwards, not inside the part itself. I'll just hit OK for now. Oh, before that, I always forget. I'll change the material to polyimide. So I'll press P and look for polyimide over here. So I'll load it and then okay. Yeah, so if you have the thickness going to the other side, you can just put the minus sign over here, and it will go to the front side. In my case, right now it will go to the back side. So here we need to update. Either press F7 in the keyboard or go home and update parametrics. So yeah, this is what happened. If I highlight this, I can know that it's inside the part itself. We don't want that. F7. Next, we will draw or design the antenna over here. So we need to make sure that we change this local coordinate system to this point. Again, I'll go to modeling, pick points, double click this point, align the WCS to that point. Next, I will select the brick again, hit escape, and then from here I will name this the ground area. The U mean will be 0.5 plus the ground width, and the max is 4.5 minus the ground width, And for the V minimum will be 17 plus the ground height, and the maximum, well, let's make it like this, 17.5, and over here 21.5 plus the ground height. Let me preview it. Some objects' dimensions are too small for the 3D model. Please set a smaller units. Okay. Let me hit OK for now. Or let me change the values to 0 for now. And hit preview. So yeah, here's the ground area. I'll change the material from here to copper. Hit load and click OK. So if I want to change the width, I'll just increase this. Hit F7, as well as the height. So if I can make it more lower, -5. Cool. Now is creating the antenna trace. I'll just make this more thinner. That will not work, so I'll try 1.5. Yeah, that's good. So to create the antenna line, I'll go to Curves, Polygon, and click Escape. To create the points, we'll give them parameters. 2.5 plus antenna width number 1. Set the parameter. For now it's going to be 0. This point is about like 16 millimeters plus antenna height 1. And then okay, yeah, it was here, so I'll make it a little bit above. Cool. To come over here, I'll change this to here. Like this. So I'll change the parameter to 2 or 4.5. Let's make a 4. Next, to go down, I'll keep the same U, and I will change the V. So like this, and the V will be okay. So that's nice. To go to this point, I'll have to set a new parameter width. I'll call this antenna width 2 and give it the value of 1. And this will stay the same. Next, to go all the way up here, I will set a new parameter and call it antenna height 2. And I will give it 21 value. Actually, this will be here. like that. Now to go back here, I'll keep the same V and a new parameter, we'll call it a width 3. Cool. So I'll click OK. And from this curve, I'll go to trace from curve and then trace from curve. Hit enter. I'll name it to antenna trace, and the thickness, I want to give it a parameter, antenna thickness, the width, so it's, I can hit preview, and the thickness for now, I'll make it 0.018, and the A width is here. There we go. And before we exit, I want to do that rounded caps like that, and hit OK, then close. Now I want to set the material to copper. Oh, it's already in copper. Wow, that's nice. How did that happen? But anyway, so if I want to change this shape or the width of the line, I can change it in the parameter list over here. So set it to 0.5 and then hit F7. If I want to change this width, I will go to so this is the first width, this is the second. So the antenna width 2, I'll make it 2, for example. Let's see how it goes. Let's make it 0 or 0.5. And if we want to do the same to the side, we will change the antenna width number 1. So 4.5, F7. If I want to make this closer to here, I will change the ground minus 4 in this case. Yeah. If I want to check the distance between these two lines, I will go to View, Dimension. I'll click this point and this point. So this is not what I want. I will click Tab and hold it a little bit to change. Yeah. I'll double click, and this is the gap. If I want it to be a little bigger, I will change the ground height. If I want to change the ground width, no, I want it to be a little bigger. That's good. So yeah, a little bigger here, a little smaller here. My math works upside down. Anyway, it works. Now I will go to Simulation, Discrete Port, and then I will select this line and this line. then click OK. Now we are almost set to go. Before that, we'll check the mesh count. We'll go to Home, Mesh View, and then we'll see the total mesh cells over here. To bring them down a little bit, we can do this. We click Global Properties, and we decrease this to 10. Then update, and we have a number of cells of more than 800,000. We can decrease this also to 15, update, or 10, update. And the smallest cell is a little bigger now, so that will help. We can drag this down until 15. Yeah, so honestly these changes I searched them online and tried to optimize the waiting time of the processing or yeah, the processing of the results, the final results. So I'll click OK, and then when I click the solver, I can change this to minus 30 dB as well, and click start. But before that, we need to make sure that we have our field monitor set over here to far field, and we add a 2.44 Hertz monitor. Okay, and then a monitor with this name already exists. Do you want to replace it? Okay, we don't want to replace it. We can replace it. Then set up solver and start. Oops. Can abort. Discard results. Okay. So yeah, I want to change this accuracy to minus 30. Then click starts. I hope this video helped you. If you have any question, feel free to write them down in the comment section below. Subscribe to my channel, and I'll see you in the next video.